Previously, we created some simple parts using FreeCAD's Sketcher and the Part Design Workbench. This time, we'll build simple assemblies with multiple bodies that can fit together. Specifically, we'll create a simple box with a lid that slides onto a lip. I'll also show you how to import a step file and use it as reference geometry to create a mounting plate or enclosure. Just like last time, if you have access to a 3D printer, you can print these parts to use them in your own projects. Now that we have a basic understanding of how to create sketches and how to use them to define features in the Part Design Workbench, we'll turn our attention to working with multiple bodies in a single project. Close your previous document if you have it open, so right-click on it, click Close Document, and let's create a new document. I'm going to show you how to create a spreadsheet in here that we can then use to create global parameters for all of our designs. So in the Workbench selector, drop that down and go to Spreadsheet. We're going to click New Spreadsheet, which is this button right here. You can also find it in Spreadsheet, Create Spreadsheet. I like to keep the names of the variables in column A and then the actual values in column B. So let's write these down. We're going to go with length, width, base height, lid height, the amount of the fillet we're going to use, thickness, and the gap between the lid and the base. So the length, we're going to do 60 millimeters. We're going to have it 40 millimeters wide. Feel free to change these to whichever values you'd like. I'm just more or less using arbitrary values to make a small keepsake box. The base height is 10 millimeters. The lid will be, I guess, the same. Let's go with 4 millimeters for the fillet. That's, a decent rounded corner. The thickness should be 2 millimeters. That's a decent thickness for 3D printing. I find anything under that gets a little too flexible for my liking, especially for somewhat rigid walls like this. 2 millimeters can be flexible if the length is long enough. You can go under that to like 0.8 millimeters, but that's going to be like 1 or 2 layers on your 3D printer. Don't expect a lot of rigidity from that. I usually like 0.5 millimeter gaps between objects. That gives it a nice loose fit. But if we want a slightly snugger fit, let's use 0.2 millimeters. So while you can reference these in your designs as, say, cell B1, cell B2, it's usually a lot easier to give these a name. You can't really reference them by the name in A, the A column, not that I have found at least. So right-click on the B1 cell, click Properties, go to Alias, and let's call this Length with lowercase l. Now this has a name, so we can call this spreadsheet and call it .length, and now we can reference this variable. It's much like you would do in, say, programming. So let's do this for the other ones as well. I'm going to label that one width. Let's call this one base underscore height. I use lowercase and underscores for my variables in FreeCAD. I don't know if that's the actual standard. I see a lot of camel case or Pascal case, but that's what I like to do because I'm used to programming in C. Let's call this lid height. Let's call fillet. We're going to call that fillet. The thickness, I will label that thickness. And gap, of course, we are going to label that gap. Okay, so notice that these cells are highlighted in yellow, which means they have an alias, and we can reference them pretty easily from our designs. To make that referencing easier, I'm going to right-click on the spreadsheet, click Rename, and I'm going to name this Globals. Because I'm used to programming, these will be my global variables. Also notice that we've got some tabs down here. These are my different views. You probably recognize the Start view, which is what you're presented when you first start FreeCAD. We can just ignore that. Globals is the spreadsheet that we're working on, and then unnamed is my 3D view because we haven't saved the file yet, or the document. So in fact, let's do that now. I'm going to go to File, Save As, and I'm going to call this Keepsake Box. Might as well go back to my actual standard and use an underscore. The reason I don't like to use dashes in names for variables when working with KiCad is because let's say I do box dash length. You notice it turns red here. That dash is actually computed as a minus sign. So it's looking for a variable called box, and then it's going to subtract length, some other variable from that. So generally not a good idea. Either use camel case, Pascal case, where you'd say like box length with capitals like that, or use underscore like that. In this case, I need to go back to length for my basic. It doesn't like that. Let's just cancel, go to alias. Good, still called length. Okay, I hope that makes sense. Don't use dashes in your variable names. Use underscores or keep it to different capitalization schemes like Pascal case or camel case. Let's go to my 3D viewer, which is this tab down here. We need to change to the part design workbench, and we're going to create a body. Notice that the body here exists separately from the spreadsheet in our tree view. Next, we're going to click on Create Sketch, and I'm going to click on the XY plane. I'm going to create a rectangle like this around the origin. I'm going to right-click in order to get rid of that tool or exit out of that tool mode. And then I'm going to round these edges. There's a couple of ways you can do this. The first way, the hard way, is you can break this coincident constraint, find where that is, delete that, and then use the arc tool, either by center or by 3 points. I usually like 3 points for something like this, and manually draw that here. There is a multi-tool or polyline tool where you can actually create different designs. So I can click, I can press the M key to rotate between different things. I could create an arc. I can make the line a little different and connect it. So that's another way you could do that. So I'm going to right click out of that tool, and I'm going to click Control Z to undo all those operations. If you've created something like this with sharp corners, there is a fillet tool that you can select. So we'll click on that, and you can click on 2 lines that are next to each other, and it creates a fillet. So let's just go around this box and create fillets for all of the corners. And you notice that it creates the points wherever I click them. And I think it might be where I click last. So I'll Control Z. Let's try a big click there and a little click there, and it creates it wherever that first click was. That doesn't matter too much. I'm going to right click to exit that tool. And I want to make these fillets all the same size. So I'm going to either press the E key or press this Constrain Equal button. And I'm going to click on that first one and that second one, the first one, third one, and the first one, and the third one. So now we have fillets that are guaranteed to be the same size, but we haven't set those yet. Next, I'm going to use this dimension tool. I'm going to use the Smart Dimension tool. You could use one of the specific tools like Constrain Distance, but I've gotten in the habit of using just this Smart Dimension tool. We're going to define the length. So you can either use this point here, which is kind of a construction geometry to give you the extents of this fillet. If you were to draw these 2 lines out, you would get to this point. This point here is the center of what would be this full circle if you continue this arc. And I'm going to take this top point, and then notice that the Smart tool tries to figure out what I'm doing here. It says, oh, you want to define something to the center point, or maybe one of the axis lines. Not really what we want to do. So just ignore that for now. We're going to come down and we're going to click on this point. That's the bottom point of our design. So I'm going to click on that. Notice that it turns yellow. I'll zoom in so maybe you can see it here. That point's turning yellow under those numbers there. So I'm going to click on that. And then you notice that it's now giving me a distance between those 2 points. So I'm going to drag this text over here and click to place it. It's going to ask me to insert a length. In the previous episode, we could define a manual length here. But what makes parametric modeling fun is we can use variables, whether it's from another part of the design or from our globals sheet. And you can click this button here, which is enter an expression. Think like on a spreadsheet, you can enter expressions. In fact, very similar to spreadsheets, if I press the equals key, it's going to bring up this expression editor. And now we have a number of options here. So feel free to start typing something, and you'll see that drop down, and it tries to suggest some things, maybe with a D in it, since I typed D. You have a number of options here. So the name of this spreadsheet is actually spreadsheet. So if I type spreadsheet, that will reference this spreadsheet here. Or we could use the label. In this case, it's globals. So if we start typing globals, you'll see the name pop up here. Notice that it's surrounded by these less than, greater than. That means it's using the label we gave it, which is globals, instead of the absolute name, which is spreadsheet. But we've accessed that, and now we can access things on the inside of that. So we use the dot notation to go into that object. And keep in mind, we could access the body too. So instead of globals, we could actually use body, but it's not found at this moment. We can use origin, which is on the tree view here. Yeah, body, you can't access body. It's got to be a feature within the body. So you can use origin, you can use sketches, anything in here, but we're going to use that globals spreadsheet. So we've got the dot notation, we're in there, and we've got some potential. So we could use, you could type A or B, that gives us some options for using one of the exact cells, because those are values. Notice that the result shows up as 60 millimeters, 10 millimeters, that aligns to the length and width. We could also use those aliases that we defined. So we want to use length, so LENGTH, so that shows up there, so we can click on that or finish typing it, and it gives us the result of 60 millimeters. So say OK, and click OK here. You notice that this dimension, this constraint, is now orange. That means it's an expression-defined constraint, that we defined it using that expression editor rather than giving it an exact number. Let's do the same thing for the width. I'm going to click on this point on the left here, and I'm going to click on the point on the right. So now we have the full width of the box. I'm going to click equals to bring up this expression editor. I'm going to type globals, use my down arrow key to select that value. Notice that the dot is already put in there. And I'm going to type in width. I'm going to use my arrow keys to select width, press enter, press enter, press enter. Now we have the length and width defined by something we set in a spreadsheet. We need to do the fillet next. Notice that I can click the dimension tool, the smart dimension tool. I'm going to click on the arc, which is right here, and it automatically knows I want to define the radius. So I'm going to move this so it's a little easier to read, click somewhere outside of that radius. I'm going to, instead of pressing equals, I'm going to click this expression editor, and I'm going to do globals, use my down arrow key, dot, and we're going to go with fillet. So I'll type that out. Notice it says 4 millimeters. Click OK, click OK. So now my fillet radius is defined. I'm going to give you an example here of purposely breaking this or making an error. I'm going to define a manual width. I'm going to use the Smart Dimension tool and click on these 2 points here. I'm going to drop that, and let's keep it at 40. Click OK, and you notice that it automatically catches this for me, which is really nice. Because I've already defined that dimension, FreeCAD says, oh, this width is invalid because you already have it set. If I click on that Smart Dimension tool and I try to click on these 2 points here to define a width, you notice that the sketch turns orange, and in the solver message, it's saying I have a redundant constraint. Now, if I were to click this and drop that and it keeps, and the sketch is still orange, I can actually scroll down here, click on constraint 27 and delete it to get rid of that redundant constraint. That means you have more than one constraint, whether that's geometric or numerical, basically overlapping with each other, and the solver can't figure out which one of those to use. So it's a good idea to, whenever you see this redundant constraints show up here or your sketch turns orange, delete that as soon as you can, because if you make a bunch of changes or additions later, those become harder to solve. If I drop this and say length 40 millimeters, you notice that FreeCAD actually catches it and doesn't allow me to set that constraint. That's one of the nice additions that they have, but you still will run into situations where you have an over-constrained design and you need to come over here and find it and remove it from your constraints list. I'm going to right-click to exit the Smart Dimension tool. We still have 2 degrees of freedom. In this case, it means the X and Y are not set for our box. And I just want to center it around that origin. So I'm going to use my symmetry tool. I'm going to click the inside center point of this fillet. I'm going to click the inside center point of this fillet. And then I'm going to click the origin. Remember that order matters. The third point or line needs to be the point or line in which your 2 points are symmetric around. So let's click this middle point, and you notice the box snaps to that center. And everything's lined up. We are fully constrained, so we can say close. Next, make sure this sketch is selected. If not, come in here, click on it. You should see the properties pop up here, and we're going to pad it. Just like before, when we set the length, we're not going to do this manually. We're actually going to use this expression editor, and we are going to say globals, just like we did before, dot, and this is our base. We're going to use base height, and I'm using the arrow keys to select those. Press enter and enter. And this is now set for us. If you ever need to edit this because it's grayed out like this, you can click on this expression editor and come in here to edit that. So I'm going to exit out of that. and we're going to say OK. As I showed in the previous episode, you can actually click on this face and we can create a sketch directly on that face. I'll show that here. So now we're editing a sketch on that face, but we're not actually going to do this. So I'm going to close out of this. I'm going to click on this sketch and press delete to get rid of it. I'm going to show you a different way to create sketches. If you ever need to do this, it's a good way to avoid the topological naming problem. I'm going to click on create sketch. I'm going to click on the XY plane. So now we're essentially drawing underneath our box here. Before we start drawing, I'm going to click close. So the sketch is still here. It's underneath the box. I want to move it to be on top of the box without actually being attached to this face. The way to do that is to look in the properties. So make sure that sketch is selected. Drop down attachment. Go to position, drop that down. And the Z determines the height of that sketch, or where it is in that Z axis. And I believe that is relative to where the sketch is. We are going to change this. Once again, we have this nice expression editor. So we're going to go globals dot base height. Perfect. So press enter, say OK. So now the sketch should be resting on top of this box, and you can avoid the topological naming problem because you're not actually drawing on a face. So if this box changes and you add or subtract faces, that sketch will still be in that exact position. So we can double click to go into the sketch, and notice we are on top of the box now. Let's click on that top to view it, and we are going to create a lip around this box so that the top can fit on it. Feel free to use the rectangle or create your own fillets like we did last time, but there's this nice rounded rectangle tool that just does all of that for us. So I'm going to draw that here, right click to exit, and notice I can't quite see the sketch, so I'm going to right click this tool. Yeah, I don't know where that sketch went. Okay, that's interesting. Well, let's click on pad, press the space bar to hide it, and it didn't show up for me. That's interesting. Let's try this again. So I'm going to click on the rounded rectangle. I'm going to draw it. And now I'm going to draw the fillets. So just put those wherever for now, and then right click to exit the tool. So I believe what I did last time is I forgot to click one more time to define the fillet because I couldn't see it when I was drawing on top of the rectangle of that box. So if that happens to you, you can disable features like I did to help you see what you're doing. Click on top. Make sure that you can see the sketch, and notice that I'm doing that. If I ever get in a weird position where I'm not looking at the sketch face down, I like using the navigation cube to make it a top-down view of the sketch. So let's zoom back in, or you can also click zoom fit, which is right here to center that in the screen. I'm going to turn the pad back on so we can see this lined up. I'm going to click out so that the pad is no longer selected. And we are going to define the width, length, and fillet just like we did before. Before we do that, let's set that symmetry constraint like we did. So click the top left and bottom right fillet to centers, and then click the origin. So now we are centered about the origin. I'm going to rezoom again. And let's use the Smart Dimension tool. I'm going to define the length, which is right here. I'm going to press equals to bring up this expression editor. Let's do globals. We're going to do dot width. And then we're going to do some math here. So I'm actually going to do minus, and I put spaces around that minus sign, globals dot thickness. Press enter. Aha, I said width. That is wrong. We're going to do length is what I meant to say. There we go. That looks correct. So click OK. And notice that it's just smaller than the length of the original rectangle. Let's do the same for the width. So let's click these outside points. Let's do this. Click enter. We're going to do globals. We're going to do dot width now. Let's do this correctly. And minus globals dot thickness, just like we did before. Okay, so now we're getting this rounded box that is inside of the original box. And once more, let's do it for the fillet. And we're going to click the expression editor. We're going to do globals fillet minus globals thickness divided by 2. Okay, so now that should create a nice lip for us there. We want to set an alias for these values that we can then reference later, especially on, say, the lid that we're going to make. So right-click to exit that tool, select our width here, double-click it to edit that value, which we can do with the expression editor. But what we want to do is set the name, which is like using an alias with the spreadsheet. We're going to call this lip underscore width. We're going to do the same with the length. So we're going to call this lip underscore length. And we're going to do this with the radius as well, lip underscore fillet. Click OK. So now those are named that we can reference. We're going to repeat this process, make another rounded rectangle inside of here. Oh, it wants me to set the fillet that I can't see. So we'll click that. So notice that turned white for a bit. That looks like a bug in FreeCAD where it thinks those constraints aren't set, but as soon as I try to move it, they turn green again. Okay, so that's good. And now I can move this inner rounded rectangle around. And we are going to use the Smart Dimension tool. We're going to set the width. We're going to bring this up. Just like we did before, we're going to use globals dot width minus 2 times globals dot thickness. So that should inset it a little bit from here. And before we continue, let's set that symmetry tool. So use the inner center points of these fillets. Click those two first, then click the origin. There we go. So now we're going to create a lip that comes up here. Let's continue with the dimension tool. We're going to set the length, much like we did before. Press equals. We're going to do globals dot length minus 2 times. Notice I can just start typing globals instead of using the less than characters. And we're going to do thickness. All right, so that's looking good there. And let's set this radius point. So click on that arc, and we'll do that inner one. So we're going to do globals dot fillet minus globals dot thickness. And if we zoom in, we see this nice wall that we're going to be able to extrude out of here. We are fully constrained. Right click to exit that tool, click close. Notice that our sketch is on the top. We're going to click pad and we get this nice lip coming up. And we are going to set this one manually. So let's just set that to 3 millimeters. Press tab if you want to see that previewed. That looks pretty good. And we have not set our carve out, our pocket, for the actual box. Right now it's just a chunky rounded cube or chunky rounded rectangle box that doesn't hold a whole lot. So let's click on this face. Let's create a sketch. You can do it the other way if you wish, where you offset that z-axis. I'm going to bring in these lines using the external geometry tool. Right click to exit. And I'm going to show you this nifty little view section button. If you click that, the camera slices to where I can see exactly where my sketch is. So I'll click it again, you can see, and then it slices there. That is very helpful for trying to draw this kind of stuff. I'm going to use the rectangle tool. I'm just going to draw a rectangle here, set my fillet so we can see it, and then I'm going to press the E key to bring up the equals constraint, and I'm going to make the top equal there. I'm going to make the fillet equal that one. I'm going to make the left side here equal that one. That has fully constrained my dimensions, but I need to constrain the position. I'm going to press the S key to create, I'm going to create, there we go, right click so you can see what I'm doing. I'm going to press the S key. That brings up the symmetry tool. I'm not sure why my cursor isn't changing. That looks like a slight graphics glitch or bug, but I move my cursor around and you can see how it's changed with the symmetry tool. So just like we did before, I'm going to set those two corners around the center point, right click to exit. I am fully constrained. And now I'm going to click the pocket button. Let's use the expression editor. I'm going to say globals. If I did base height, that's going to carve it all the way through. So we want that nice thickness there. So I'm going to click that again. So I'm going to subtract out the thickness, which should be 2 millimeters. So 10 millimeters minus 2 millimeters gives us 8 millimeters. Click OK. And now we have carved out that pocket. There is another tool that I'm going to show you in a bit that can do that for us. It's a little weaker and sometimes doesn't work very well, so you can always carve out a pocket manually if you need to. It's just harder to follow very complex shapes, but basic shapes like this works very well. I'm going to adjust my camera, Click OK on tasks. Notice that my buttons are grayed. I can't click on anything, so check my tasks pane. And click OK because we are done with this pocket. And notice that the pocket shows up here. Just to demonstrate, as we've done before, I can click on pad 01, press space to view that. The pocket goes away. I can click on this pad. The lip goes away. I can also set the tip. Right click, set tip. And now if I were to export this body, you would only get this pad. You wouldn't get these other features because this is where the tip is. It only computes this linear or sequential combination of features down to wherever the tip is. And because it stops here, if I exported this, you would just get this shape. No lip, no pocket, no nothing. So to reverse that, right click on my pocket, set tip, and you notice it brings that back into view automatically for us, but we can always press spacebar to view the other features. So this is where we are at right now. I'm going to right click on body. I'm going to rename this, and I'm going to say base. And I'm going to press enter, and now that body is called base. Now that we have the base designed, we want to create a lid that fits over top of this. So I'm going to zoom out here so we can see what we're doing. I'm going to click the create new body, and notice I have two separate bodies in my keepsake box document. I might as well rename this one now, so right click. I'm going to call this one lid. What you'll find is that you cannot use the external geometry. So I'm going to show you this real quick. Let's create a sketch. If I click on external geometry, I can't select any of this because it is in a separate body. That is a problem because we want to design a lid or something that is based on this shape here. To do that, we need to use a separate tool. So I'm going to right click, click close, get out of that. I'm going to delete this sketch so we can kind of start over here. So we've got our shape here. I need to use something called a subshape binder. This is a kind of a confusing name. It allows me to bring in another shape or another body as a proxy. It doesn't actually show up as a shape. If you tried to print it, it wouldn't do anything. It does allow me to use external geometry based on that. It's kind of like a reference. If I change the original shape, the subshape binder does or should update automatically. So that's why we want to use the subshape binder. There is another thing called a shape binder. The shape binder does the same thing. It creates a reference shape in your current active body, but it does not change or update when you adjust the original shape. It takes a snapshot in time when you click that button. Generally, you want to use the green one, the sub-object shape binder, or subshape binder for short. To use that, I'm going to make sure that lid is active. That is my active body. So you notice it's highlighted in purple on this tree view. I'm going to select base. This is a little weird. So lid needs to be in light purple since it's the active body, and base needs to be selected. And then I'm going to click my subshape binder, and that creates a binder under the active body, which is lid this case. Now, if I click on base, press space to make it disappear or hidden, I have this nice yellow outline reference of the base that I can use for creating shapes. So if I take my subshape binder, I can actually click on a face. Notice that it's highlighted in green. I can click sketch, and now I'm sketching on top of that lid, that face. So I can sketch on subshape binders like they are objects, but if I tried to export this body, nothing would appear because it's only a reference. It's not actual geometry. Let's close out of this sketch. I'm going to delete this sketch. And instead of doing it that way, which is one possible way, it is prone to the topological naming problem, but since that's mostly fixed, that would probably be fine for version 1.0 or version 0.22. Let's create a sketch. I'm going to create it on the XY plane. So now I'm sketching on the bottom of this lid, more or less. Click top to go back to that view. Let's close out of this to set the Z-axis on this like we did before. So in the properties pane, come down to attachment, come to position, and guess what? We are going to use this expression editor because yay, parametric editing. We're going to change this to globals. We're going to use base height, and we are going to set our gap here. So we're going to use plus globals gap, which sets it to just above 10 millimeters. And what that does is sets it to this bottom part of the lip here with a little bit of a gap above it. We'll see that when we finally model the actual lid. Double click to edit this sketch. In fact, if I rotate just enough, let's look at the left side, and I can rotate this camera around. you can see that the sketch is hovering just above the bottom part of that lip. All right, let's go back to editing this. I want to see the front and right, or not. I actually want to see the top because this is a sketch. Just like I did when creating that pocket, let's bring in some external geometry. I'm going to bring in this top line here, this fillet, and this side line here. Right-click to exit those. Sometimes I like to turn off the shape so I can see what I'm doing, and that gives me a good place to edit. Let's reset our camera, and we're going to create a rounded rectangle just like we did before. Got to set the fillets. Click those. I'm going to press the E key so I can use the equality constraint. Click the top line of that. Click the fillet and one of the fillets that we brought in from external geometry. Click the length or vertical line and the vertical external geometry. Now the lid is the same as the base. I'm going to right click to exit that tool. You probably want to use the symmetry tool, but another way to line this up is you could use the constraint concentric. I'll press C to do constrain concentric, right click, or you can press this tool here. So with C, we bring up this tool. We can actually line up, say, these points on the fillets, and now the whole thing is lined up. I'm going to right click. I actually don't like it that way in case something changes or I move that fillet. If that point on the reference geometry changes, this might be a problem and I have to come back and fix it. So my preference is to use symmetrical around the origin, since that's not going to move more than likely. I can press Control Z in order to undo, or the other option is I come down to my constraints. I can find that constraint point here. You notice that it turns a slightly darker green, and I'm going to press Delete to get rid of that constraint. Now I can move that box around again. So let's press S for symmetry. I'm going to click these 2 points and the origin like we did before. Now it lines up. It looks like our sketch is fully constrained, so I'm going to click Close to get out of that. Let's click the Pad tool with that sketch selected. I'm going to use the expression editor. I'm going to do globals, and I'm going to do lid height, which is also 10 millimeters. Click OK, and click OK. Let's bring that base back in. So I'm going to click on base, press the spacebar, and you can see how these are starting to line up. If I zoom in here, oh, there's that slightly tiny gap that we put in there, which is excellent. It's always good to have a little bit of a gap, because if you try to make them exactly equal, things likely won't line up, especially when you 3D print, unless you have some seriously good tolerance on your printer or CNC machine, however you decide to make this box. Let's fix my camera. I'm going to hide the base again. As we did before, you could create a sketch on this bottom and carve out that pocket. I'm going to show you a different tool, which is known as the shell tool or the thickness tool. I'm going to click on the face on this underside. So there's the top, and I've clicked on this face on the bottom side of this lid. I'm going to click on this thickness tool or the shell tool, and you notice it automatically figures out where the bounds are, and it creates that pocket or series of pockets for me to create this shell. The thickness we want to set according to our spreadsheet, so we'll do globals, we'll do thickness, and we'll click OK. So this shell is now a little bit thicker. There's some other modes here to play with, but this default is good enough, so click OK. In my experience, this thickness tool isn't the most robust, so if you have very complex shapes and you try to use it, it may not always work. So keep that in mind, and there are other generally more complicated ways to make shells like this if you need to, but there's more than one way to do it. It just requires more button pushing. If this thickness tool does work, that's great. Otherwise, no, it might not, and you might have to do something else. Now, let's create a sketch on the bottom of this. We could create a sketch on the XY plane and move it up with the Z axis as we've done before, but since I like to be lazy and I know the topological naming problem is mostly fixed these days, I'm going to click on this lip, and I'm going to click sketch to create a sketch on that lip. Notice that we are now looking at the bottom of this lid. So if I rotate the camera, you can see where the sketch is located. I'm going to go back, click on bottom so that we're looking straight up at it. Let's create another rounded rectangle. Don't forget the fillets to click again. So now we have this rounded rectangle. I'm going to right click to exit that tool. I'm going to create a symmetry constraint around the origin as per usual. Right click to exit that. Let's set the width. So I'm going to use this smart tool, the smart dimension tool. I'm going to click these 2 points, bring this up, click it. I'm going to use the expression editor to do globals. Instead of using globals and calculating this manually, I'm actually going to reference something from the base object that we drew before. Remember when we set those names for the length, width, and fillet for that lip. So I'm going to reference another variable rather than using the spreadsheet. To do that, remember, I can't actually reference that body, or maybe I can. That's news to me. Oh, it has to be a property on that body, so that doesn't work. What we need is that sketch. So let's cancel out of this. I'm going to look at base, and it was sketch 001, so that's what we're going to reference. So let's create this width again here. I'm going to go to this expression editor. I'm going to call sketch 001. Notice that we have the name versus label here since we didn't rename it. So sketch 001 is fine. To access some of the constraints that we've set, capital C constraints, another dot to go into those constraints, we called it lip underscore width. And we actually want to add our gap here. So let's get that from our spreadsheet. There we go. So 38.2. Click OK. Click OK. And notice that it creates the width here for us. That should be the width of that lip we defined minus a little bit of gap space. So it should fit fairly snugly. Let's repeat that for our length. So we're going to click those. We're going to do, oops, I meant to click this button for the expression editor. And we are going to do sketch 001 dot constraints dot lip length plus globals dot gap. And I'm going to press enter and enter to set that, just like with the width. And you can see the width and length set here. Once more, I'm going to do the fillet. So click on one of the fillet lines, click out, enter. Let's do sketch 001. Let's do constraints dot lip fillet plus globals dot gap. So that should set the fillet to 3.2 millimeters. Say OK, and that looks perfect. We have a fully constrained sketch. Click close, and let's bring up this base again. You can't quite see it. Let's carve out this lip first. So with the sketch that we just created selected in the tree view, let's click the pocket tool, and that's going to drop that lip down in there. We're going to do this, and we can actually access this pad tool. Remember, that's how high we made that lip. It was not based on anything in the spreadsheet. We just added this. So that is a parameter that we can use. So in the expression editor, we're going to say pad 001. That was that pad operation, not one of the sketches. And we're going to say length. I'm going to press tab. Oh, that goes over to OK, so I shouldn't do that one. Let's plus, and let's do globals, and let's do my gap. Actually, we shouldn't need to do that because we are already offset. So we don't actually want the gap. The offset is already built in from the top of the base to the bottom of the lip here. So we just need that 3 millimeters. And it's not length 2, it is length 1. So make sure to select that one correctly. So now we've got 3 millimeters. I'm going to click OK. And now we have that fully defined. Let me turn on the base so you can see this. There is our box. And this is interesting because I can go to my globals. So I can either double click on this sheet or single click on this sheet, or I can select one of the tabs down here. Let's say I change this width to, I don't know, 100 millimeters. We'll make the box much wider. If I come back in here, you notice everything updated automatically. In fact, let's make it square so you can see this. Let's do 100 millimeters for both. I'll come back in here and boom, perfectly square box. Everything updates, which includes my subshape binder. So if I get rid of this, you can see the subshape binder here. That automatically got updated whenever this base was updated. And then everything based on this subshape binder on the lid was also updated. So let me turn that back on, and you can see that in action. So this is a fully parametric design with a spreadsheet that I can update these variables. Now I'm going to press Control Z to go back to where I was, which is 60 and 40. And I'm going to view my keepsake box, and you can see it right here. Let's turn off this subshape binder. Let's bring this base back in. Notice that we can't really see into this box. That makes it really difficult to work on things where you've got complex internals. In fact, I don't even know if this lip is working for us. That's a problem. We might be able to use the subshape binder, but no guarantee that that's going to ultimately help us. If we really want to see what's going on, we need to change the appearance of some things, or we can slice the shape with our camera. One way to do this is, let's go to our lid. I'm going to right click on my lid and I'm going to say appearance. That brings up something in the tasks pane. We can change the color. So let's go custom appearance, ambient color. I don't know, let's change this to like an orange or something, like a nice light orange. Click OK. Might conflict with the subshape binder, but so what? If I click out here, oh, look, that's orange now. That's good enough for what we need. And I deselected it, so let's make sure I've got that selected. The display properties come back. I'm going to change this transparency to 50. That's always a good number. So now when I click away, you can see inside of the box, and you can see how this lid was made. That fits perfectly on top of the base, and this lip should fit nicely within there with a nice gap. And we have a 0.2 millimeter gap all the way around, including the top and the bottom. And I think I see an issue here. So if I go to the front, you'll notice that this gap here on the top and bottom is not the same distance as the gap on the left and right side, which means I think I forgot a piece of the variable here. So this is where using transparencies can actually really help me. Let me show you how to slice the view again if you want to get another look at this. So I'm going to keep this transparent color because I actually really like it. You can also enable clipping planes. So if we go to View and click Clipping Plane, this creates a plane that we can then slice the object to take a look. So let's try X. Notice it slices that away. We can do Y, it slices both. I can also just select Y, and that allows us to see inside the box. Z also works. So if you wanted to see, say, just the lid, notice it slices this object under here. So I'm going to look at Y. I'm going to move my camera to the front, and I'm going to zoom in. And just like we saw before, sure enough, there is a difference between this gap and this gap, and we want those to be 0.2. If we really want to check this, I believe I can use the measuring tool, which will let me click this point and this point. And if I rotate my camera, that is 0.2. That is the gap we want to see. The measurement tool is here, result 0.2. So let's reset this. Let's click here and about there. So that's 0.1. It's not being exact, but yeah, there's a difference. That's a problem. So let's close out of that measurement tool. Let's get rid of my clipping planes. In fact, I'm going to close my clipping plane. And let's go fix that sketch. To fix this error, let's go into our pad here. We're going to go to Sketch 003, double click that to edit it. And this doesn't look like the one we want to edit because that is the full lid. So close out of that. What we actually want is Sketch 004. The other way to slice the camera that I showed you earlier was this view section when you were in Sketch. This is what we want to edit because this is the actual lip that we are creating here. If we double click on this and click on this, that gap should actually be 2 times that gap. So I'm going to enter 2 asterisk for 2 times. And now it should be 38.4 instead of 38.2. I'm going to do the exact same thing for the length. Come in here. Let's add the 2 times. Notice that the spacing doesn't really matter for the math. Click OK, click OK. And this fillet, I don't believe we need to do 2x because it's the radius. So it should be the distance here is the gap, and then the distance here is the gap rather than the entire width, which should be 2x the gap. So we're done. Click Close. And now we can view front like we did before. And these should be about the same, which looks really good. Feel free to try slicing again. So View, Clipping Plane. Let's clip along the Y so we can see inside there. Click on the camera to go to front. And we are going to use the measurement tool. When using this, be very careful about where you click. That's how we got that 0.14 we did before. So we have a little bit of space. I'm going to click on this point here, which is that corner point. And you notice that doesn't, oh, nope, it'll line up with that point here. So let's see if I can actually click on that point. I might have to use the clipping tool so I can actually offset the clipping tool by using this here. So I can move this in. So let's move this all the way in here so we can see where we're actually clicking. And I'm going to click this point right there. Oops, let's reset this because it clicks somewhere else. And we actually want to go between, say, this point and this line. Where I click, that should be where the point is. There we go. Close enough. So now you can see it's between these 2 points, and it's 0.2 millimeters. That looks really good. That's what we wanted to see because that is the gap. So I'm going to close the clipping tool. I'm going to close out of the measurement tool, and our lid looks really good with that lip. Sometimes these edges can be sharp, especially if this is made out of metal or you have like an elephant's foot when you're doing 3D printing down here. That can make some sharp edges. So sometimes I like to round these. We've created fillets here, which are the rounded edges. We could use the fillet tool. So to do this, I like to make sure nothing's selected by clicking somewhere else in the 3D view. I'm going to click the fillet tool up here, and now it's asking me to select edges. Sometimes faces will work, so I like to do edges. So I could click these edges around here. I'm going to click all of the ones that I want to create a fillet on, and then I'm going to click the preview button, and you notice that rounds it. Fillets can be really hard for a 3D printer to make, especially on the bottom, because it can go in more than 45 degrees. And so you might need support structure, or it might be too small and it's not going to create a good fillet on the bottom. So what I like to use instead, if this is going to be the face that I print on, or this is the face that I print on that's on the bed of the printer, let me cancel out of this. I prefer to use a chamfer, which is a 45-degree angling. So click that tool, make sure nothing's selected. I'm going to click the edges, the same edges I clicked before, and click preview. That looks pretty good. I'm going to change the size to 2 millimeters, press tab so you can see that. I like that even better. I don't know, I think it looks slick. So feel free to play with that and click OK. So that looks really good for the lid. And for some reason, the lid lost its appearance. So I'm going to right click on that, go to appearance, click on custom appearance, change this back to that, I don't know, orange color. There we go. Click close, and I'm going to change the transparency to 50. I'm not sure how it lost its transparency, but there we go. That looks really good. Now I want to add a chamfer to the bottom of the base. So right click on this, say active body. You could also double click on this to make it the active body. If I click away, notice it's highlighted in purple. And now we are editing this sequence of features under the base. So I'm going to click on the chamfer tool. I'm going to rotate my camera. I'm going to click on each of the edges that I want to add a chamfer to. And once I've done that, I'm going to change this to 2, and I'm going to click the preview button, and there we go. Click OK. The chamfer and fillet tool are also not the most robust. Sometimes if you try to add features, like I try to extrude or pocket from here after I've done the fillet and chamfer, or come back here, try to add features before them, they can often break. So a general rule is to do your chamfering and filleting at the very end. That helps prevent stuff from breaking if you try to add a chamfer here and then do more features or try to change something up here. Now that we are done with that, I'm going to click Save to save my design. I'm going to click File and Export. Oh, select objects to export. Even though I have an active body, the body was not selected. So I'm going to click on base to make sure that's selected. Now go File, Export. And now it's going to do the file name, dash, and the body, which is base. So let's save the STL. And I want to do the same for the lid. So I have to export bodies separately. So I'm going to click on lid, file, export. Lid is now the STL file that we're exporting. And we are done. Feel free to save again if you wish. And we can now 3D print this by bringing those STL files into the slicer. In your slicer program, you can choose to print the base and lid separately or at the same time. I'm going to open, and I'm going to open the base STL file so you can see that appearing here. And I'm going to open and double click the lid. Since they are small enough to fit on my printer's bed, I'm going to do both at the same time. Notice that there is some overhang here on the lid because that's how we designed it. That is an easy fix. So I'm just going to click the rotate button, make sure that my lid is selected, and I can either enter degrees here or I can grab these little arrows and flip it around to 180 degrees. If it's not lying flat on the bed, you can see that by the light blue face there. You can click the lay flat button. I often find that that messes up the orientation, but that's fine. We can rotate again to 90 degrees there, and we can click the move button and move that part next to the base. So let's move the base in. I can grab these, move those, and move one axis at a time so they just about line up. That looks really good. I'm going to make sure I've got PLA selected. I don't need support material for this since there's no overhang. I'm going to click slice, and when that's done, I'm going to zoom in, and you can see that because the chamfers are 45 degrees, no support's needed. Actually, I'm going to go ahead and say generate support. Let's slice again so you can see this. Sure enough, no support material is needed. This is done and ready to print. So I'm going to click Save to Disk, fire up my 3D printer. In about 2 hours, this should be good to go. We'll send the G-code file off to the printer, and in a couple of hours, we'll have our keepsake box. Assuming the printer has been calibrated and doesn't have any layer shifting issues, the lid and base should fit together nicely. If you want a fun challenge, try adding bumps to the base and grooves of the lid so that they snap together and stay. There are a number of sites on the internet where people share their CAD designs. If you watched my Introduction to 3D Printing series, you're probably already familiar with Thingiverse and Printables. These are great for sharing designs made by other people and are often ready to be 3D printed. Most include STL or step files that can be imported into FreeCAD. However, if you need a detailed CAD file of something like, say, a Raspberry Pi, these sites aren't the best. To get that, you'll want to go to grabcad.com/library. Here, people submit designs, mostly for the CAD practice and not so much for 3D printing. You'll need to create a free account to download anything. I'll search for Raspberry Pi 5 and sort by most liked. Click on the top Raspberry Pi 5 entry and download the files. Notice that this model was created in SolidWorks, which means that we can't open the original model. However, we can import the exported step file to use as a reference. Unzip the downloaded file. Step is an open file format that includes all the parts, whereas STL is just a merged mesh of all the parts. Step is much easier to work with as a reference. Go ahead and close out of the document that we were working on earlier. Let's create a new document and go to File, Import. Find that Raspberry Pi 5 folder that we unzipped, go into Step, and we're going to import the step file. Wait a moment while that imports. It's fairly complicated. Feel free to leave these import settings as default. Click OK. Give it a moment. This file is somewhat large and a fairly complicated model. And you can see we have a nice imported model of our Raspberry Pi. For whatever reason, it's not facing up. The top is actually the side. To fix that, we can go to Raspberry Pi 5, right-click, say Transform. I'm going to set my rotational increments to 45 if it's not done already. I'm going to grab this dot here, and I'm going to rotate it so that it is actually on its side. So now, when I go to make something, it's a little easier to reference, like, say, an enclosure. Click OK. Notice that you could also go to the properties, and you could adjust the axes here, say 90 degrees, set X to 1. It's a vector, basically, of the XYZ that's normalized, and then you set that angle. In the Part Design workbench, click Create Body. Make sure that's the active body, so that should be light purple up here. We are going to drop this down, and we're going to find the PCB, since I want to make an enclosure, so let's click on that. That's that top plate. There we go. So I click on that. That's the plate. That's just the PCB. And we're going to click Create Subshape Binder. And now I'm going to hide the full imported step file. And we have our PCB ready to create some type of enclosure or mounting plate for it. Notice that I'm missing the actual mounting holes. I'm going to Control-click each of these mounting holes in the PCB, and I'm going to click Create Subshape Binder for each of those. Let's hide the pie again. There we go. Now I have the actual mounting holes on my PCB. Let's click Create Sketch. Let's put this on the XY plane, and now I can import external reference geometry by clicking each of these edges. I can click my mounting holes, like so. Oops, that did not work. Right click, I'm going to Control Z to get rid of that one. Go back, click that edge. There we go. That looks better. Right click, let's hide these subshape binders, and now I've got my reference geometry that I can use to create some sort of mounting plate or enclosure for the Raspberry Pi. In the next episode, I'll show you how to design for heat set inserts so that you can create secure mounting points. But for your challenge, I'd like you to create a mounting plate for one of your development boards, like an Arduino or a Raspberry Pi. Don't worry about adding screws just yet. You can use pegs so that the board just rests on the plate. If you're feeling particularly ambitious, you can also design a lid that snaps into place. Show off your design on X, Instagram, or LinkedIn with hashtag #DKFreeCAD. It can be a screenshot or an actual 3D printed part. Don't forget to tag DigiKey as well. Once you've finished your challenge, join us again to learn about creating mounting holes and using heat set inserts.